All right, here we go. The centroid. So this is the second half of 5.2. We did the in-center yesterday. So let's talk about something quickly before we go to that program that I use, that GeoGebra program. Let's talk about how do we find the centroid. Okay, well, the centroid is finding the medians. So that's a new word. Let's write that down. Okay, finding the median of the triangle. Okay, so what in the world is the median of a triangle? Let me just, let's see where I want to start. Okay, we'll just do this. So if I had a line segment, I could do this on GeoGebra. I'm just going to do this right here. Okay, so if I had a line segment, Now, let's go right to GeoGebra. Is that all right? I'll show you on that. So let me get out of that, and there we go. There's GeoGebra. And so let's put I don't understand why. Maybe it's because of the pen. Why it made a big old line. Yeah, see, when I use the pen, it puts this big old line on there. I don't know why. So when I use the mouse pad, it just does this. I'll use the mouse pad. All right, so here's a triangle. So what is the median? Well, the median, it goes from the vertex to the midpoint of the opposite side. You're probably thinking, I thought we already did that. We already did the midpoint of the opposite side. But what did we do when we found the midpoint of the opposite side before? We didn't go from the vertex. We did what to it? We went from the midpoint, but we made what kind of a line? Not a parallel, perpendicular. Okay, we made a perpendicular line from the midpoint. Remember that? That was the circumcenter. Okay, you can see it's confusing remembering all of them. Would you agree? So you got to review them every single day. So this time what we're doing is we're not going to make a perpendicular bisector. We're going to go from a vertex to the midpoint of the opposite side. So I have a thing right here that finds the midpoint. So I click on midpoint, I click on this, and there it is. That's the midpoint of this line segment BC. So now what do I want to do to find the median? Remember, it's median, M-E-D-I-A-N. So what do? Make a segment from where? A to D. Yeah, let's go from A to D, right? And right there, that right there is a median. So how many medians are there on this triangle? There's 3 of them. So let's put the midpoint on this side, right there. Let's put a midpoint on this side, right there. And now what we're going to do is we're going to connect from B to what? What's the median from B? B to what? What point? F, right. So from B to F, because it's the opposite side. Okay, if I go B to D or B to A, it's not going across. They're not opposite sides. So this side right here, AC, is opposite angle B. So that's what we do here. We got one more to do. Now, these two are going to intersect, all right? But guess what's going to happen if I connect from C to E? It's going to do what? It's going to, I said these two intersect. So if I go from here to here, what do you think is going to be true about all 3 of these? They're going to intersect as well. So those lines are what kind of lines? Give me a word. Starts with a C. Concurrent, not congruent. Okay, they are concurrent lines. All right, so, okay. So there we go. So what is this point right here? Let's put a point. What do you think we call this point right here? The centroid. Very good. Okay, so let me just double click on this. Oops, I don't want to do that. There we go. That's what I want. And let's name it centroid. All right, so there you go. That's the centroid. So is there anything special about the centroid? Well, there is. Now, this is a little bit different. Okay, so bear with me right here. I'm going to put some line segments in here. So do you see from E to the centroid and then from the centroid to C? Does everybody see that? Okay, what I'm going to do is I'm going to make a segment, because that's one big old long line right now. Okay, it's not really split up between there. So what I'm going to do is I'm going to go to my little segment tool, and I'm going to click here, I'm going to click here, and I just made a segment. All right, and now I'm going to make another segment from the centroid to point C right there, and then, this is a little bit time consuming, but Then I'm going to go over here. I know you don't see a lot of this on the screen. You can kind of see it peeking through a little bit. But down here, let's see. I think is it this one? No. Let me see which one. Well, let's do this. There we go. It's that one right there. That's it. Okay, so now what I've got is this. I'm going to, sorry. Again, I'm pretty new at this. There we go. Distance or length, that's what I want. Okay, so I click this button. You can kind of see it at the bottom of the screen there. It says distance or length. If I click on this right here, it's going to give me from the centroid to E, and that's 4.3. Now watch very carefully. What I'm going to do now is I'm going to click on this from the centroid to C. What do you think? Let's just take a wild guess. What do you think the length of it is going to be? Do you think it's going to be the same? Okay, so Ben says twice bigger. Okay, anybody else? Okay, so you looked in the thing, right? So Abby said 2/3, and I'll show you why it says 2/3. But Ben's actually right. This right here, from the centroid to C, what do you think the line segment, the length of the line segment is going to be? Give me a number. Okay, let's click it. Now, it says 8.5. Why do you think it says 8.5? It's probably the rounding, okay? But if I do this, if I figured out, see, it rounds to 1 decimal place right now. Let's say I round to 2 decimal places. It'll probably, let's get rid of this so I can see it. So right there, yep, see, 8.52 is exactly twice 4.26. Everybody understand that? You see why it rounded it? Because the 5.2, the 2 only rounds to 5, right? So it looks like it should be 8.6, and it technically is, but if we round it, that's why they have that. So this is the shorter segment, okay? From the midpoint to the centroid is the shorter segment, and then from the centroid to the vertex is the longer segment. And how much longer is the longer segment than the shorter segment? It's what? It's 2 times. It's exactly twice as big. Everybody see that? So what they say is this. They say from the vertex, hope you're paying attention, hope it's that interesting, okay, to not understand this stuff. So from the vertex to the centroid is 2/3 of what? Is it 2/3 of the shorter one? No, it's twice the shorter one, but it's 2/3 of the what? The whole entire segment, okay, from E to C. You understand that? The books always say 2/3. They always do that. But students get confused on that a lot of times. So basically what I say is the longer segment is twice as big as the shorter segment. That's pretty easy to understand, isn't it? Yeah. So what about the shorter segment? The shorter segment is what compared to the longer segment? It's half, right. Okay, if the bigger one is twice the smaller one, then the smaller one's going to be what? Half of the bigger one. You guys paying attention? You getting this? Okay, seeing a lot of blank stares. I don't know if that means you're just getting it, it's too easy for you, or you're just not understanding. I'm not really sure. So the longer segment is twice as big as the shorter segment. Is that just true on that one? Probably not. It's true on all 3 of them, okay? I'm not going to go through all 3 of these just to show you, just because of the time, all right? But yeah, it's going to be true with all of them. Let's just make up a number. What if from the centroid to F, what if that was 3? What would it be from the centroid to B? It'd be 6. Easy enough, right? Okay. What if from the centroid to D was 4? What is from A to the centroid? It's going to be 8. Okay. Or what if I told you from A to the centroid is 12? What is the centroid to D going to be? It's going to be 6. Easy enough. Do you agree? All right. Now, you know what they're going to do eventually. They're not just going to put regular numbers in there. What are they going to do? Yeah, they're going to put algebraic expressions in there. Exactly. Okay, they're going to put x's in there, right? X minus 2 or 3x plus 5 or something like that. Yeah. I don't know if you remember, but I've said it several times, but the geometry we do the rest of the year, the basic idea of the geometry is basically the same. Okay, all we do is kind of the same stuff. Girls, let's pay attention to me up here. Something's going on. I need you to pay attention. So, the basic idea of geometry has been the same since we started all these pictures, except we just go to different figures, right? That's all we're doing. We're doing the same thing. Wouldn't you agree? We learned something about this particular, picture right here, and then we find a relationship between the sides or the angles and all that kind of thing. And then we do an algebra equation, right? Right now we don't have any algebra. They're going to put some on here, okay? So they're going to put some algebra on here, and then we just relate them to each other. So I'm not going to do this off the top of my head. I don't have one off the top of my head. But what if this was like x plus 2, and this was 3x plus 7 or something like that? What would you do? That's right. You would say this one, the long one, is equal to 2 times this short one. Does that make sense? What if they give you the whole thing? So what if they give you the whole thing is 8, let's just say. All right, so from E to C, and let's do this. Let's go back to this. Now I got to change this. There we go. What if the whole entire length was 8? So from here to here, and then let's say this is where the centroid was right there. And what if I told you from here to here was, let's say it's 12. Oops. There we go. Come on. What if this was 12? All right? And let's just call this a little bit A, and let's call this a little bit right here B. So how would I find A and B if I knew the whole entire thing? And if this was the centroid? See what I'm doing? I just took the triangle away. I just took that line segment. How would I do that? How could I find either A or B? Okay, because this is 2/3. That means this is going to be what? 1/3. 1/3 of what? Of 12. So the easiest one to find is not the 2/3 one. You could do it, right? But what's the easiest one to find? The 1/3, the little one, okay? So A is equal to what? 12 over 3, because it's 1/3, right? And so that would be 4. So A would be 4, and obviously B would be what? 8. Make sense? Now that was about as easy as I could make it right there. But you know what they're going to do. Again, I don't know if this works out. I'm just doing this off the top of my head. But let's say this was x plus 2, and this was 3x plus 1 or something like that, okay? So how would I solve for x, and how would I find the lengths of those segments? Well, you could say, well, actually, let's say we don't know that this is 12. Okay, what could we do here? So what if all I know, and again, I don't know if this is going to come out even. This could come out to some weird number, but that's okay. How would we set this up?
You would do x, parentheses, x plus 2, multiplied by 2.
Okay. Well, you could do this. You could say the 3x plus 1 is equal to what? Is it? It's 2 times. Right, this is double. This is 2 times x plus 2. Does that make sense? And then you could solve, right, and then you could solve for x. You see what they're going to do? Again, I don't know if these numbers work out right. I don't know. Let's just see if they do. Who knows? This is 2x. Yeah, they probably give you some. Subtract a 2x from both sides. Oh, yeah, it does work out. Works out pretty nice. So x is equal to 3. So if x equals 3, what's this little segment right here going to be? It's going to be 5, right? It's not going to be 4. It's going to be 5. What's this going to be? It's going to be 10. And that's how you would do something like that. Does that make sense? So you don't set them equal to each other because this is definitely shorter. This is only half of the length of this. Or this is twice as long as this one. Okay, so you'd set it up like this, and you're good to go. Make sense? It's not so bad, is it? All right. Did I give you extra homework on this like today? Or let's see, what did I give you? Yeah, 23 to 37. So you should, I don't know if you were able to do all 1 through 12 or not. I don't know if it had Centroid on there. I don't know, did it? I don't have the problems in front of me, so I'm not really sure. You were the one, some of them you could do? All right. So now what you're going to do, you're just going to finish it off. You're going to do 1 through 12, and then you're going to add on 23 to 37. So now you should be able to do all of those. So this is section 5 too. All right? And it's pages 217 and 218. This is for Alex in case he's actually watching the YouTube videos because he wasn't here to get the lesson plan thing from yesterday. All right. So Alex, if you're there, how you doing? All right. So that's your homework, but I'm going to show you one more thing. I'm going to stop recording this because this one I have to show live in class and I don't have a camera or anything to show it. So I'm just going to stop right there.